Hi, welcome to another video from SQL Maestros. This is part 4 of troubleshooting SQL Server I/O performance and bottleneck issues. Before this part, I have recorded 3 parts, 1, 2 and 3, and I strongly recommend that you can watch those parts first before you watch this one. But nonetheless, you can also watch this part independently. In part 1, I talked about DM virtual file stats DMV and how you can use that to track latency factor on your data and log files. In part 2, I had talked about perfmon counters like average disk second per read and what numbers are good, bad, and how you can troubleshoot them using performance monitor on Windows. In part 3, I showed how you can use various DMVs to track queries and workloads that cause maximum I/O. In part 4, which is this video, I am going to talk about PAGEIOLATCH wait type. Now, wait types are a big concept, and a holistic discussion of wait types is beyond this video. Right in this YouTube channel, I have recorded another video which talks about the basics of wait types and what are the common wait types, and I would recommend that you can watch that to understand what really wait types are. But since you're already watching this, here is a very quick introduction about wait types. When you send your workload to SQL Server, and if your SQLs and your workloads are not running in a timely fashion, there are prominent chances that your query, your workload is waiting on some or the other resource. So wait types are always happening inside SQL Server engine for some or the other resource. And when your workload is waiting on a resource, a specific wait type gets assigned to it, and there are more than 700 odd different wait types inside SQL Server, and the SQL Server team keeps adding more wait types with every new release. So wait types are always happening. There are your workload wait types, and there are system wait types also. So as I said, do watch that other video so that you can get more details about wait types. Now, wait types can be categorized like IO wait types or scheduler wait types or even memory wait types for that matter. We are focusing on PAGEIOLATCH wait type, which comes under IO wait types. Now, there are a couple of other IO wait types like write log or even IO completion, etc. But in this video, I am only going to focus on PAGEIOLATCH. Now, PAGEIOLATCH, now you can see on the screen it says PAGEIOLATCH_star, which means there are different versions of this wait type. You have PAGEIOLATCH-SH, which stands for shared. Then you have PAGEIOLATCH-EX, which stands for exclusive, and PAGEIOLATCH-UP, which stands for update. Now, the moment we talk about shared and exclusive, here you can see there is a concept of latching, and PAGEIOLATCH happens when your query, your workload is reading pages, the SQL Server data pages, the 8K pages off the disk, and they're waiting on to latch a 8K buffer in memory onto that page. So if the read takes time off the disk, the query, the workload will wait on PAGEIOLATCH. Now, please don't confuse PAGEIOLATCH with PAGELATCH, because PAGELATCH is another wait type, and that has to do completely with memory and the in-memory buffers. This has to do with IO, so you note that it is PAGEIOLATCH. So what I'm going to show you in this video is how you can use SQL Server system wait types and DMV wait statistics to track PAGEIOLATCH metrics like wait time and wait count, etc., and record this and see, do you really have an IO performance issue? So let's get started with the demo. This demo is going to be a bit long and of course tricky. I mean, the introduction itself has taken so much time. So without any further delay, let's jump into demonstrations. So the first thing I'm going to do is like what I did in my previous videos, I'm going to engineer this disk, and I will make it normal. Then let's jump into some DMVs here. Now, if you see PAGEIOLATCH percentage, I've just put this as a character out there, wildcard, to track all the different types of PAGEIOLATCH wait type, and when I execute this, you will see that no workload right now is waiting on PAGEIOLATCH. I'm using this DMV DimOS waiting task, which will give me all the tasks inside SQL Server that are waiting on PAGEIOLATCH. I've just done a filter here. If I simply just do a select star on waiting task, sorry, not where, select star, and I would get all the different wait my sessions that are waiting on different wait types. But I want to see my wait type, my sessions and workloads that are waiting on PAGEIOLATCH, and I can see none right now. There's another DMV called sysdmos wait stats. This gives me historical metrics on different wait statistics, wait types. If I execute this, I will get all the different wait types and their counts and what has been their total cumulative wait time, their max wait time and signal. Now this information is not very useful unless we do some mathematics around it, and mostly you would do something like, let's say, order by wait time descending. Let's say not max wait time, we'll just do order by wait time and we do descending. But remember here we have to exclude some system wait types like for example FT, IFTS scheduler, yield, sleep task. These are some of these extended events, timer event. These are system wait types that we can exclude, for example dirty page pull, etc. Now I will just comment this for a moment because I'm not going to use the wait stats this way. I'm only going to focus on my wait type, which is PAGEIOLATCH SH, or even I can give a wildcard there, but this is good enough because I'm only going to read. And when I run this, I can see that currently my wait time task count is about 1595 and wait time is about 170,000 milliseconds. So I'm just going to use the 3-digit number 170 for the sake of simplicity. Now in this demonstration, what I will do is I am going to engineer and simulate an IO performance issue, and then I will show you how these numbers can be helpful for you to identify if you really have an IO problem. So a quick summary: we have this DMOS waiting tasks that will help us track our tasks that are waiting on PAGEIOLATCH on real-time basis. So this is a real-time DMV, and this one DimOS wait stats is a historical DMV, which will basically give us cumulative historical snapshot of all the wait stats, and we are filtering on PAGEIOLATCH. Before I begin my demo, I will clear the wait statistics. I can do that using this command dbcc SQL perf, and I supply the DMV and I call it clear. When I execute this, you can now verify that all numbers will go blank, 0. So let's begin with our simulations. Here is a small script that I will run to ensure that I am running my simulation only for 15 seconds in each run. So what I'm going to do is I'm going to simulate some clients that are going to cause a lot of read. These are nothing but simple workloads that are reading data pages. These are a bunch of different select star statements that will run off the databases. In each run is going to be of 15 seconds. So I'm going to run the workload, run this for 15 seconds, and then close the workload and go back and record the numbers. This is going to be fun, and this is a bit tricky, so bear with me. So let's get started. I will first switch on to my demos, and I would click on add clients, and now workloads are running. And while the workloads are running, I'll simply go and click on execute, and this is going to run for 15 seconds and stop after that. And while this is running, let's go and check a few things. So you can see that some of the workloads are now waiting on PAGEIOLATCH SH, and these are all different sessions. And while they're running, you can also see that wait time is now 51,000 milliseconds. So this workload ran for about 15 seconds and you got a wait time of about 51,000. Now let's assume that you ran this at 9 o'clock. So I will use Excel, and I'm going to use basic functionality here to record this information. Let's say at 9 a.m. my wait time for PAGEIOLATCH was, let's say, 51,000 milliseconds. Let's go back to SQL Server and Let me simulate this once more, and it will also help you understand what really I am doing. So I'm repeating this now, and let's assume I'm doing this at 10 o'clock now. So I'm going to execute this perf statement, and let's verify that all our wait stat numbers have again got back to 0. And I'm going to simulate the workload. So let's go and run add clients, which are going to add multiple command windows that are going to read data. I'm going to do this for 15 seconds. So let's go and execute that. And now watch this. If I execute this and keep an eye on the wait time, 20,000, 26, see it's increasing, 29, 32, 34. And if you look at the real-time DMV, you might see some, okay, nothing as of now. Looks like the workloads have stopped. Yes, they have stopped. So 15 seconds was done and workloads have stopped. So in the previous run, you saw that I was showing you a few workloads that came under real-time DMV OS waiting tasks, and now I was just trying to show you how cumulatively the data gets add up in this wait time. And now I am going to record this again in Excel. Let's say this was at 10 o'clock, and this was go back what the number was. So this was about 43,000. So I'll just put 43 out there. One last time. Oops, sorry. And then I'm going to run this again to show you one last time. You're back to 0, and let's go and simulate the workloads you're running, and you want to do this for 15 seconds again, and look at the real-time DMV, and you can see some workloads waiting on PAGEIOLATCH, and you can see your cumulative data on wait stats. 31,000, 33 is still running, 35, 36, and looks like this time we stop at 36,000. So this is the trending that we are trying to do. Let's say this was at 11 a.m. and this was 36,000. Now what am I trying to do? I am trying to baseline how my IO performance is. What are my different wait time for PAGEIOLATCH SH over a period of time. Now this is just a very simple basic example of how I would baseline my data, and I'm doing everything manually, but in real world all this has to be automated, which means you got to collect this data and put it into your baseline database and create trends and see the trend over a period of time. Now if this is what the trend looks like, 50,000, 43, 36, well, it's increasing, decreasing, that will always happen. But now here is the fun. What I will do now is go back to SQL and just simulate slow SQL. I'm just going to slow down the disks a bit, and I will run this stored procedure, and I'm just trying to engineer something here and clear off the stats again. Let's verify. Back to 0, and now I am going to add clients again, and we want to do this for 15 seconds. So let's execute this and back to our monitoring, and now you can see many of our workloads. Do you see the number of workloads now that are waiting are much more than previous examples that I showed you, because the disks are really slow now. And if you look at our wait stats, and you can look at the number there, do you see that it workload 15 seconds are over and workload has completed? This time we see a number of 174,000. This is much higher than the numbers that we have recorded earlier. So let's put down 174,000. Let's do it once more. So we go back here and clear off the wait stats again, and let's go and run the workload at clients. We again want to be fair and do it for 15 seconds. So let's execute this, and now I'm going to show this to you. Look at how the number climbs up so quickly, 60, 70, and with every second it's jumping about 10k, 109 and 19 and 27. Look at the wait time if you keep an eye on this. And if you look at real-time waiting tasks, okay, looks like the workload has completed, and this time our numbers are 165. So if I go back and record this for, let me just quickly drag this and get it up to some point. Okay, this is not correct, so I should not take at 12, I should at 11 go all the way to 5 p.m. That's right, and this was 165. Now you can see that 174,000 or 165,000 are high numbers. They are slightly abnormal compared to the previous numbers. You are able to pinpoint that because you have a baseline to compare with. When you have a baseline, when you have a benchmarking done, then you know that the other numbers are good, bad, or ugly. But let's say these numbers were not there, then it's very difficult to tell, it's very difficult to guess or figure out that are these numbers good, are these numbers average that we see in our environment. It's very difficult to say that. That is the reason why you got to trend this, you got to record this data, so that you, whenever you have a performance issue, you can go and look at your CPU metrics, your IO metrics, or your memory usages, etc. And if you have numbers collected at different times, you can compare and you can see the peak and the valley and the snapshots. Now, because I had this baselining done, I know that these numbers are not good. Let's assume that things were back to normal, and the numbers were like, let's say 45,000. At some point it was 65,000, and then let's say at another time it was 54,000, so on and so forth. And let's ended this with at 60,000. Now what am I trying to tell you in this video, in this demonstration? I'm actually trying to show you two things. One is how you can use weight statistics, and more precisely, because I'm talking about IO, I am trying to take PAGEIOLATCH as an example, but you can apply this logic and this technique to any weight type. So let's talk about PAGEIOLATCH. So what I'm trying to show you here is how you can use this technique to capture weight statistics data and PAGEIOLATCH metrics from our weight stats DMV, record it at frequent intervals, maybe let's say every 1 hour, and then create a trend out of it to see where things went bad. So if I select this data and I do a quick analysis, let's say create a line chart, and I can get something like this, and then I can clearly see that somewhere here I have a performance issue, because I can see that my baselining has been around here, which is like 50, 60, 70, but during this time, during between, let's say about 11 and 1, I had high IO usage, and this is where my disks were running slow, and then I got to investigate. Now unfortunately, SQL Server only maintains cumulative data. Now this DMV that I have been demonstrating, weight stats, and how you can use PAGEIOLATCH weight type to identify if you really had an IO performance issue, this number is cumulative. Now that you see it is 165, if I don't clear the stats and if I go and run my workload again, you will see this will only add up further. So when they are running and I execute this, you can see it will constantly increase and it will only go higher and higher. So there are two ways on how you can record this data. You can take a cumulative snapshot every time. That's one way of doing it, and the other way of doing it is in an automated way. When you are running jobs, you take the snapshot and then your jobs can clear the weight stats and then capture again. So before every capture, you're resetting it back to 0. That's one way of doing it, or you can always take it cumulative. Either way, you got to find out the delta. That's really what we want to do. So if you are taking let me close the workloads. Either way, whether you are clearing off the weight stats after every collection or you're taking it cumulative, you got to find out the delta. In this way, let's say now the number is going to be very high. Let's say 638,000. So if I want to find out what my trending has been, I got to subtract this from a previous snapshot to find out the delta. So I see different people using different techniques. For me, collecting the data and clearing it off and then collecting again is sometimes really very simple, because I have my snapshot at every period of time. So I can use that also for trending. But yeah, that's completely your choice as to what you're comfortable with. So what I've shown you, that we are collecting this data, and we should get it recorded in a baseline database in a table, and then we can use our trends here to understand where things went wrong. Now I can clearly see that I really had an IO performance issue at between 11 a.m. and 1 p.m. And then now I want to go back to the history of SQL Server as to which workloads were running and what really was the problem at that period of time. Remember that SQL Server maintains limited history, so it is up to you to record a lot of data. So I just showed you how I'm recording the data from WaitStats DMV, but there are many other DMVs like dim exec query stats you can capture. And when you capture that as a snapshot, for example, don't capture very frequently because it is a lot of data and it is very overwhelming. You need to capture at maybe bigger intervals, and then with every capture you can put a timestamp to it, and then when you're capturing a lot of this information and maintaining a history, you can go back into time, you can go back into history and look at the workloads that were running between 11 a.m. and 1 p.m. to see where their IO intensive workloads or what really was going on. And with that historical data, you can even pull out historical execution plans and see whether plans were good, whether missing indexes, whether a lot of scans happening, etc., etc. So with this, I was a quick summary is, this part 4 was how you can use your wait statistics, more precisely this wait type PAGEIOLATCH. And remember, PAGEIOLATCH is being used here to see your IO performance issues when mostly when you are reading data pages off disk into memory, and if disks are slow, that read is going to take time, which I just engineered. And then how you can track the metrics, and when you have abnormal metrics, how you can even identify whether it is normal or abnormal. The key learnings is really here is that you got to baseline and benchmark, because then only you can tell if a number is good, bad or ugly. You can tell that only if you have another number to compare with. So this part 4 was one of the so many different techniques that I have been showing on how to troubleshoot IO performance issues. Thank you very much for your time. My Twitter is _Bansal. Do follow me, and please, if you like this video, do share this video, subscribe to the YouTube channel. I hope to be back soon with another video. Goodbye and have a nice day.